Alright, I want to model to you how to solve a combo circuit problem. As you can see, here's my circuit. I have a resistor in series running to a parallel circuit, and then through another series, and the voltage is 220. You can see I've numbered each resistor. That's just to help me make it a little bit easier to keep track of what's going on. Okay, I'm going to start this now. And the first thing I want to do is simply write my total battery voltage in a slot, and I've actually already done that with writing there. VT is going to be 220. I've also set my problem up so I see I, V, and R for each one, and you should do the same. And then what I like to do is I also like to write on my paper Ohm's law, I equals V over R, and so you just keep track of that. First step is to find the total resistance. So what I do is I simply work in my circuit, and for the little loop right here I'm going to do 1 over 200 plus 1 over 225. I get my total resistance for that, and that comes out to be 105.9. I now add that to the 175 here because now they're connected in series. So 175 plus 105.9 equals 280.9. And I need to keep track of that, and I have that written right there. Now that I've done the lower loop, I want to consider my whole loop. So again, I'm going to work this out. I'll do it up in the right hand corner. And I look at my top resistor, it's 100. So 1 over R equals 1 over 100 plus the next loop is 125 in series 150. That is 275. So it's 1 over 275 plus my bottom loop, which we said was 280.9. That equals, all said and done, 58.15. And that's my resistance for the loop. Now to get my total resistance, I add everything up. So I come over here, my total resistance is, the first resistor is 50. For that loop right here, we said it was 58.15. Then the bottom resistor is 250. That gives me a total resistance of 358.15. And I'll record that in the proper spot. Now I'm going to use Ohm's law, and I'm going to solve for I. So 220 divided by 358.15 gives me my total current, which is 0.614 amps. Looking at my circuit, I now try to take care of the easier things first. Resistor 1 is in series, so it'll get the same current as the total current. So that's going to be 0.614. I times R gives me my V, and that comes out to be 30.7. Back in the circuit, my last resistor, number 8, also is in series, so it gets a total current, and that's going to be 0.614. And again, I times R gives your total gives your total voltage, and that's 153.5. Now I have to look at my big loop right here. So as I do this, I look at my whole loop, and I'm going to write my information down. I'll do it right here for the big loop. R was 58.15. I for the whole loop was 0.614, and V, after you do I times R, comes out to be 35.7. I look at my loop and ask myself what is by itself in the loop, and that is resistor number 2, which is the 100 ohm resistor. In that case, it gets all the voltage that we just solved for, which is 35.7. So V2 is 35.7. I now do V divided by R, and that gives me 0.357 for the current through line number 2. The next step, as I look at the middle line, that resistance for the middle line is 125 in series with 150, so that is 275 ohms. The voltage has to be 35.7. The rule of voltage, it has to be the same across each line, and I solve for my current. V divided by R gives my current of 0.129. I look at my loop, and again, 3 and 4 are in series with each other, so they have to have the same current, which is 0.129. So 3 and 4, 0.129 amps, 0.129, and I now solve for the voltage. I times R, 16.23, and 19.35. Finally, I have to do the bottom loop here. I'll do that right there. There are a couple ways to do this. This is just the way I will show you right now. The bottom loop, the resistance was 280.9. The voltage has to be 35.7, and I solve for the current, which comes out to be 0.127. Since resistor 5 was in series, it gets all that current, so that's 0.127. I now know I and R. I multiply to get V, which is 22.2. Alright, since my total voltage has to be 35.7 across the whole thing, I'll subtract 22.2 to get my voltage across that last parallel loop. That comes out to be approximately 13.45. I'll record that for V6 and V7. Now I just simply have to get the I values, which is going to be V divided by R for each of those, and that works out to be 0.067 and 0.059. Together those two would add up to equal 0.127. Hopefully you'll find this helpful as a way to solve a combination circuit.